Good morning all. In this box I have a Thomson High King DDS238-2 Zigbee. So what is that? Well, according to the manual, it is a single phase smart meter. So what is this device? Well, it's another of these DIN rail mount devices that will fit in a consumer unit or a distribution board or box. And it's an energy meter, single phase, which measures all sorts of things: voltage, current, power, and of course the time-based derivatives, so energy, kilowatt hours, power factor, and all sorts of other things, I think. Yes, impulses per kilowatt hour. Oh, that can be changed, can it? That's interesting. Total energy, kilowatt hours, positive kilowatt hours, reverse kilowatt hours. So it's that kilowatt hours going backwards through it, which they will from a solar power system. Reactive energy, kilovolt amp RH. Balance, kilowatt hours, real current, real voltage, real active power in watts, reactive power, power factor, and frequency, of course. Let's take it apart because that's a bit more interesting. I'll just slit the, that's drifted off a bit, the quality sticker so that breaks in half. Now there are two screws. One is behind the spring-loaded DIN rail attachment, but they'll come out. Now I bought this from the Thomson official store on AliExpress. Curiously, this is the first thing I've ever bought on AliExpress. I had to set up an account. I've only ever used eBay before. How strange is that? Right, this should come apart, I think. Thought you'd like to see the reveal, so that's the front off. So there is a little board sitting on top here which has a liquid crystal display on it, a push button, 3 LEDs which show through these 3 LED holes. This board comes off because it's mounted on little pins, and underneath it there is a, it's a Zigbee module. Let's have a look at that. It's a model ZS3L, part number Zigbee IVAP, and a serial number. So this is definitely Zigbee. Now, if you're feeling a sense of deja vu, yes, I have taken apart something very similar to this. I've got another one of these DDS238-2s, but it's the Wi-Fi version. This one I thought I'd buy the Zigbee version just for variety. So this board should come out if I splay these little catches like so, and then I'll just bend that to whichever side is better, and I'll put a link to that video of the Wi-Fi unit up there. It is virtually identical inside. So inside we have a big black box here, and that is a thumping great, is it 80 amp relay? Yes, 80 amp it says there. I'll try and get some light on that in a minute so that we can see that. That is sitting across live in, that's live in probably there, and live out. Now on live in there's a yellow wire. On the neutral bar, and this is simply a copper bar that links the two neutral connectors together, so neutral is just passed through, but it is also brought in, well, because it has to power the power supply that powers this unit, but also of course it allows this unit to measure voltage between yellow and white. Now current is on a shunt. There's a piece of that copper bar which has got a bit of a coating on it, so it's obviously been designed as a current shunt. So between blue and red you've got a very small voltage which will then be multiplied up, and that gives you your current, and then from voltage and current it can work everything else out, watts, power factor, frequency, and all that stuff. I'm just going to see if I can get the part number of this relay and get a data sheet for it. So this is the Zhejiang Great Electrical Company Limited, and it's a latching relay. Now this one says 12 volt 80 amp switching capability relay. The one in here actually is marked 9 volts, so you can get different types presumably, and you also presumably can get different bespoke copper legs coming out of this relay, because the ones in here, well, one of them has a little S bend in it there, and the other one of course has the, it's hard to get the light on it, but it has the little shunt with the positions for mounting the blue and red wires for getting the current. Lighting's a bit off at the moment, but crucially this is a latching relay so that it doesn't have to have current continuously fed into it to hold it closed. You can latch it open and you can latch it closed. So it includes the most important hallmark of a smart electrical meter, and that is that you can remotely cut people off, shut off their electricity using the big relay. Now there is an app, well, it's the Tuya Smart app. This is Tuya compatible, so we'll fire up that Tuya Smart app a bit later. And I've noticed that the user interface for this Zigbee unit, not specifically because it's Zigbee, but I think because it's newer, is far more advanced than the user interface for my Wi-Fi unit, so perhaps we'll do some comparisons. Live comes in on the yellow, looks like it goes through that 681 capacitor. Neutral appears to go through this 101 100 ohm resistor, so it looks like this is a sort of capacitor slash resistor dropper. Power supply components, got a little inductor there, 3 electrolytic capacitors, and on this side we've got 2 little inductors here, so possibly more power supply components. And here's an opto-isolator, and the opto-isolator, you can see the 2 wires coming out of it go to this little terminal block, and this terminal block is an opto-isolated output version of one of the 3 LEDs on here. Crucially, the LED that flashes, the speed of which determines how many watts are going through this meter. So I'll just put this back together and then we'll fire it up and see what it does and see how it differs from my Wi-Fi. Oh, I need something to pull that out. My Wi-Fi DDS238. Just got to get those pegs to sit on there. Little plastic pegs sit in slots on the PCB to align it, but that looks like it's gone back together. Pop this little display and button board on top and put the lid on. Okay, by way of a small diversion here is my other DDS238-2. This is the Wi-Fi unit, and you can see the impulse LED is going 10 to the dozen. I think because the sun's out, we're getting almost the full 3.6 kilowatts from the solar panels, so that's going flat out. Now if you notice, this is upside down. It just happened that it was easier to put the lives in on the top here. In fact, I'll take the front panel off this fuse box and we'll have a look how it's wired. So here it is with the cover removed. I'll use this wooden stick so I don't electrocute myself. So live from the solar panels is that one. It did go into that breaker, this B16 MCB. I moved it to the DDS238 and then put a small link wire between the breaker and the DDS meter, so this is measuring the full solar power. There's a neutral, sorry, the black wire here runs up to the neutral block up there, so that's a small wire because it just provides power for the power supply inside this meter. So yes, that. Now I think because I'm putting another socket on the outside of the house for charging my electric car, I'm going to move this meter over to these 2 positions and put, well, now I'm not sure, some sort of RCBO in this position for that additional outside socket. This breaker here, well, this is an RCBO actually because it's got the little test button. This is for the outside 13 amp socket, which is sitting next to my solar inverter. Now I need to put power to this thing, mains that is, so I thought I'd chop one of these little half-meter extension leads in half. I've just realised actually both the lives are on one side and both the neutrals are on the other. So I'm going to have to strip this back a lot further because I've got to get live and neutral in opposite ends of this thing. So I'll do the stripping and ferruling and back soon. Those are done. Now that one is input mains, isn't it? And on here it says live in is 1, live out is 2, and there are 1 and 2. Neutral is 3 and 4. In and out doesn't really matter too much, but we'll follow that guide anyway. So live in is 1, neutral in is 3, according to the little diagram. So that's, do that up to 2.5 newtons. So that's live and neutral in. So that should power this thing up. But I'll also fit live and neutral out onto here, and then I can power a load like an incandescent light bulb or something like that. Right, I've got power bank mains going into the unit. I've got a 100-watt light bulb coming out. I'm just going to put a piece of wood under there so I don't melt anything. That should do it. Let's turn on the power bank. Oh, the light comes on. And a flicker. And do we get anything on the display of this? Yes, we do, but it's not backlit, so it's not easy to see. Have I got a torch? Yeah, there we are. It's lit up by a torch. Now, the default display is just a whole bunch of zeros. If you press this, nothing actually happens. You have to press and hold it for about a second, I think. So that's slightly fewer noughts. That's 6 zeros. Minus, so that's probably the reverse kilowatt hours. Oh, that's E, is that? Yes, sorry, the shadowing is a bit tricky. So V, 230.5, there's probably a decimal point in there. Yes, there is, 230.5. I'll tilt that end up. And I might try and get a better light on this. Right, that'll have to do. I haven't seen that pulse light flash yet. It'll be this one, won't it? This third one. So I'm waiting for a red flash on there to indicate power going through this unit. So press and hold. I is 0.4, so that'll be current. Ooh, what's that? P, 934. Oh, 93.3. Is there a 4 point there? Yes, I think there is. So that's the 100-watt bulb. Ooh, what's that? I can't see what it says. Oh, Q. So is that power factor? Well, that shouldn't be 0.4. Oh, that's weird. That's jumping all over the place. Okay. Oh no, that's power factor 1. Yes, it's a resistive load, so it should be a power factor of 1. Q. What's Q? We'll have to look into that. F is frequency, so 50. Wow, 2 decimal places. 50.24. That's very precise, isn't it? Yes, this is H with a load of zeros after it. And then the next one is L. So they're high and low, obviously. And C is 1600. Now you'll see here that it says 1600 impressions per kilowatt hour. So the little LED here flashes 1600 times for every kilowatt hour. Now with a 100-watt bulb, it's going to take a while to clock up a kilowatt hour. I haven't actually seen that flash yet, which is interesting. After C, we have, oh, back to, well, it's actually 7 zeros, 0.0. I think it is 1, 2, 3, 4, 5, 6. No, 6 zeros, 0.0. So we need to find out what all that stuff is, but it's very difficult to film this display. So let's get the app up and running. Now on my other DDS238-2, the Wi-Fi one, the one that's in the distribution box, I found that if you press the button 3 times, it actually clicks the relay. You can see the lamp's gone off, so the relay has clicked over to the off position. And this little warning light here lights up red if the relay is off. So this little warning triangle says relay is switched off. So let's do a triple click again. and that turns the relay back on. I don't think this is documented in the little manual. Double click doesn't seem to do anything. If I do now single click, okay, so it timed out. Single click doesn't do anything. You have to do this press and hold for about a little bit more than a second. It's quite irritating. If you press and hold for 5 seconds, I think it does an init, but it doesn't reset everything, I don't think. And if you press and hold for 10 seconds, you redo the Zigbee wireless thing. Now this is Zigbee connected to my app, so let's get the app running and see what we can see. Now I'm using the Lidl Home app, which you briefly saw there. It's terribly slow, this thing. It is essentially the same as the Tuya Smart app. If you try to reverse out of it, it says tap again to exit. Oh, they've changed it. It used to say tap again to exit Tuya Smart, but now they've altered it. So, but it is essentially the same app. Now we've got the Zigbee IVAP meter there. In fact, if I go to Office, it will reduce the number of items in here. So the Zigbee IVAP meter, is it here? Yes, it's there. But I've also got the Wi-Fi power meter. Now that's the Wi-Fi DDS238, the one that's in my distribution box. And this is odd because it has this enormous button, which I'm not going to press because that will switch off my solar power, which I don't really want to do. And then you've got this electrical panel, and it shows you the wattages. Oh, that's a fair amount of power coming out of the solar power system, isn't it? I mean, the maximum theoretical is 3.6 kilowatts. Well, it's 3.47. And it shows you things like accumulated kilowatt hours for today, all-time accumulated kilowatt hours, which is 5 megawatt hours, and then accumulated kilowatt hours for each of the months going back. But it doesn't really show much else. There isn't much else on there. Now, compare that with this unit, the Thomson High King unit, same model number. So I'll go back to the big button and I won't push it. Go back to here, and now we'll look at the Zigbee IVAP meter. I'm not sure what IVAP is. I'm assuming it's current voltage and power, maybe? I don't know. But let's go into that. And this is completely different. It's much better. There's the on-off switch. So if I press that... Oh, are you sure you want to switch it off? That switches it off and puts that little red light on. And we can switch it back on. But we've got much more stuff here. A graph here. Active power kilowatts. Oh, let me turn my... Did I turn the bulb off? I think I did. Let's turn that back on. So active power should soon come up with, well, it's 0.1 kilowatts, isn't it? 0.094 kilowatts, there we are. Reactive power, power factor, and let's see what else we can see in here. Well, the first thing is there are 3 of these graphs. You've got forward power consumption, kilowatt hours. Actually, it's more about kilowatt hours is energy, not really power. Another graph of forward power consumption, I don't quite know why. And then the reverse power consumption, so nothing's clocked up there. And that's because I'm putting power through this thing in a forward direction, I presume. So 3 graphs. Now what's in here? Details. Well, loads of stuff. So total power that's gone through this meter, positive charge, reverse charge, there isn't any of that. Remaining capacity. So does that mean when I use all the capacity of this thing up, there'll be no remaining capacity? I mean, it's a lot of kilowatt hours, so it'll take a while. What is it, in fact? It's 100 megawatt hours. That could take several years. Comparative power, balance of electricity, reactive power, total... Oh, there's loads more. Total power cost, positive charge cost, reverse charge cost, photovoltaic, balance of electricity cost, carbon dioxide emissions, current leakage, frequency, temperature, minus 50 degrees. That's pretty cold. Phase voltage on A, B phase voltage, C phase voltage. Well, this is only single phase. Phase currents, total active power. Oh goodness, there's a mass of stuff. And that's it, total power factor. So for the 3-phase models, I presume that's why you've got all this stuff. But that is a lot of data. far more than the Wi-Fi version of this, which is unbranded. So I can't be sure that it's a Thomson High King. This one is. Oh, I think I just saw that light flash. So it is clocking up the power from this light bulb. Let me see if there's more stuff I can see on this app. Well, there's data. So let's go into data. And that's got another graph. There's also temperature here. But I'm not sure that this thing has a temperature sensor in it. So maybe some other models have a temperature sensor. But there's also up here settings. Devices setting up, password, switch prepayment, balance energy, unit price for electricity, recharge, clear energy. Ooh, there's a clear energy thing. That's interesting. Over voltage protective settings. What I wanted to see was is there a setting for changing the number of pulses per kilowatt hour? Meter settings, carbon emissions, meter number. I haven't found it yet. And actually on the front screen, I didn't actually scroll this up. We've got active power, so 94 watts, power factor, voltage. Now these are all real time by the look of it, because the voltage one certainly is changing. Well, it was. Current 0.4 amps. Temperature's obviously not got a temperature sensor, because it's showing minus 50. Frequency, 50.24. I'm not sure how quickly this updates. And then this bizarre available power thing. Oh, it's actually minus 999 megawatt hours. How interesting. There's a view operation record and an alarm log. But you can see masses more stuff on this meter than the Wi-Fi one I bought some time ago. However, for my electric car charger project, where I want to charge the car at the same rate that electricity is coming from the solar panels, I'm not going to use any of that Zigbee stuff. I'm not going to use the app at all. In fact, I'm going to use this opto-isolated output, which is just a collector and emitter here for the opto transistor, and it is simply a repeat of this pulsing LED, which just I saw there. And that's going to be connected into the Arduino, and I'm going to measure the time between pulses. Now, you've got a figure here of 1600 impressions per kilowatt hour, so I need to know, based on my measurement of the time between pulses, how many watts is going through this meter. So I need to do some sort of calculation. I'm going to come back to that in another video, because it's giving me a little bit of trouble working that out. But anyway, today I just wanted to get this meter running, show that it works, show what it measures. But actually, when it comes to it, I'm only going to be interested in the real-time watts or kilowatts. And I'm going to do that by measuring the pulses on that opto isolator output. So for this video, it's probably got quite long, not sure, but I'm going to call it there. Let's do the triple click to switch the light bulb off, because it's probably getting quite hot. Yes, cheerio.